Hi everyone, my name is Peter Bouza and I work with a company called Vision Analytical. Today I'll be presenting to you a presentation that I gave in June of 2025 at the Reliable Plant Conference in Chicago. As you can see the name of the title, it's called Going Beyond Particle Counts by Unlocking the Power of Dynamic Image Analysis, and then it also says ISO 21018-1. So as you can tell, this is to go over the new ISO 21018 and how dynamic imaging has made a start in the industry of fuel lubrication. So again, this is what we're going to be doing today. We're going to be going over fluid monitoring, particle contamination monitoring, and how dynamic image analysis plays a role in this, especially with the new ISO standard. We're going to talk a little bit about the ISO standard. We're also going to talk a little bit about how image analysis works and how the current well-known method of APC, automated particle counting, or light blockage works. In addition, we're going to talk more about what the word particle contamination monitoring, which is quoted in the new ISO standard. So here's the new ISO standard. Couple of details behind it. It was released in October of 2024, so very new. It also recognizes the value of the current technique of light obscuration or automatic particle counters and how it's used in this industry. It does provide procedures and definitions for using these new particle and contamination monitors in the lab and outside the lab. And it also recognizes the fact that some of these new particle contamination monitoring methods may not be calibrated the same way that other automated particle counters are currently calibrated. Here's a copy of the first page of the definitions in the standard. I think this is a very good point to mention is that there's two main definitions. One is what everyone in this industry is very accustomed to seeing, which is what is an automatic particle counter. These are the light obscuration or light extinction equipment that exists. Also, if you come down to the bottom, you'll here in the middle, you'll see that all of these methods, this one method in particular, optical light extinction or light blockage, they are calibrated as per the ISO 11171. When you move down to the next definition, it mentions what a particle contamination monitor PCM is. And it mentions that it does do measurement of concentrations of particles suspended in a fluid and cannot be calibrated in accordance with ISO 11171. So very clearly points out that there are particle contamination monitors that exist that are not necessarily calibratable by the 11171. So again, it does mention laboratory-based equipment, and that laboratory-based equipment for this market does require special environments and specialists in labs that do take time. So it does clearly mention the amount of time that it takes to send a sample back to the lab. It also talks about the fact that there are instruments that are being developed for particulate contamination monitoring that can be used near the workspace, or that basically means in the field, online or inline. And it also mentions that the traceability standards, so the ISO 11171, may not be a way to calibrate these new automated particle counters or contamination monitors. It also mentions the fact that a lot of the new equipment that's out there is designed to be a little bit more easy to use, kind of a go, no go, pass, fail type of criteria. And again, it keeps on mentioning the fact that some of these new techniques, which is the main focus of this ISO standard, may not be checked with the ISO 11171, but they are checked with other standards. Okay, so and I do mention here in quotes the fact that the instruments are being developed for contamination monitoring, but again, in hydraulic oil, but again, may not be tested to traceable to national measurement standards. And that's where it keeps on referring to the ISO 11171. So we keep on saying this ISO 11171. I thought I'd mention for one page at least what that means. So here's what the ISO 11171 looks like, and it's called the hydraulic fluid power calibration of automatic particle counter. So this is the light blockage equipment. So in light blockage, very traditional. This is the method that's been used for counting particles in photography, oil analysis. The way it basically works is you have light blockage. You have particles that go through a flow cell. As they go through a flow cell, the light blocks, the particle blocks the light as it goes through, and that creates a pulse. And then the length of that pulse tells the instrument to calculate a size. So it assumes all particles are round. To go a little bit more into detail of that and some of the drawbacks and the reason why this ISO standard came about, there is a little bit of a concern. So light blockage or automated particle counters will do what's called a chord length. That basically means that depending on which way the particle flows through the flow cell, if it's in one orientation or the other, it could be the same type of particle, but if it's slightly different orientation and it's irregular, which most particles are irregular, except for bubbles and water droplets, it would give you a different size. So for example, if you look at a particle going in sideways versus a frontal view that's highly irregular or plate-like, you'll get two completely different particle size. So these would be actually listed at a different ISO class code because there were different sizes. So that's a little bit of a drawback. In addition to that, you also have the fact that uh, it's not absolute. It's going to be measured slightly away from the edges because particles that are up against the edge flow slower, and it can't really tell uh, differences between translucent particles and non-translucent particles. So that basically means that if you have a highly translucent particle, um, it could actually be a bit strange, the results that you get, because the light can go through it. So, and also it can't tell the difference between bubbles and real particles. So there are some few drawbacks, but still it's a very traditional method. It's been around for a long time and it's excellent. But still, here we are because the new ISO standard is recognizing several techniques. Now, as far as the techniques that the ISO standard is recognizing, dynamic imaging is not the only one. There are several. So as you can see here, there are a lot. So it's a large standard, goes through a lot of detail. When it goes down to automated particle counting, it goes down about 3 steps here. And this is where dynamic image analysis is. So that's why what we're going to be focusing on today is what dynamic imaging can do. So it goes through this table, which is pretty good. It talks about, whether it can be online, offline, what are some of the size measurements and restrictions, and what things you will get. Okay, so this is a very good table to look at. I really enjoy seeing it. I thought it was very well done in the ISO standard. But let's take a dive into image analysis and see why we need image analysis. If particle counting already exists, why will we even need image analysis? So the reason we would need image analysis is because, okay, you're in a lab and you're running a sample and you see that your ISO codes are high for some reason. And you start to think and you're going, well, can it be an air bubble? Maybe I shook the sample a bit too much and I didn't get the air bubbles out. But then again, if I get the air bubbles out and let's say I sonicate it, well, if I sonicate it, if I have water droplets in there, I could break up my water droplets, and then those droplets can actually break up into more pieces of smaller droplets, and it'll affect some of the lower class codes. Or what if I let it settle for a while so the water droplets go up, but then that's going to say, okay, well, maybe some of your contaminants are going to float down, and you never know. You just don't know what you're going to come up with, right? So you're getting these numbers, and there's always the question, what is it? What's in there? So when you find this kind of a problem, the first thing you do is you have to go find an expert, right? So you have to get the sample, send it to the lab. They're going to do all this analysis, and they're going to try to do all these different things to try to, by process of elimination, try to figure out what it is that's going on with that sample. Are they really a high code? Should you worry? Should you not worry? But at the end of the day, this requires an expert and it takes a lot of time. And this is one industry where you really don't have time. You really need to identify things right away. So that's why image analysis was created. So image analysis is gaining popularity in many industries, including the fuel and lubrication industry. As a matter of fact, besides the ISO 21018, there are ASTM standards that already talk about image analysis for the fuel and lubrication market. So there is a lot of activity and people looking at the use of image analysis. Why is that? Okay, the reason is because it does give you the particle contamination monitoring capabilities, the counting. It does give you the classifications, but it also gives you the ability to look at images. Okay, so let's go into a little bit of depth of how image analysis, dynamic image analysis works. So dynamic imaging, as the name says, it's dynamic, so in nature. So particles are in movement, right? So as the particles pass through a sensing zone, a light and a camera are used. Very simple. Particle images are taken. As these particle images are taken, they are basically saved. So every whole image is saved, and then there are let's say on that screen there might be, maybe on every image there might be 20, 30 image 30 particles on every image. Every particle is categorized. So every single particle, there's a thumbnail of it saved, and there are 32 shape calculations made of every particle. The reason that shape measures are made, not only size, but smoothness, circularity, opacity, different measures. The reason that many shape measures are made of every single thumbnail, every single particle, is because it allows us to differentiate one particle from the other. Because this is a number-based technique, it's a direct measurement. You're looking at every particle, you're doing a measurement of every particle, you are able to give particle concentration. So particle concentration is a capability of dynamic imaging, which is very important, obviously, for this industry. And in addition to giving the reporting codes, you also have the ability to get particle concentration of just entire sample or subsections of the sample. And it will also be able to differentiate a bubble from a water droplet from a real particle. And we'll go over that in a minute and show you some examples of that. And again, as I mentioned, thumbnail images are saved for every particle. And one thing that's very important to understand is this technique is very adaptable to being field-based. There are many techniques that are mentioned in 21018, and many techniques which many of you people in the industry are familiar with, that may not travel very well because of temperature differences, because of alignment issues and things like that. Dynamic imaging is one of those techniques which is very transportable, so you do get field-based abilities. So that's how it works. Pretty simple to understand. Runs and flows, takes images, high resolution images, and saves thumbnails of every single particle. What does it give you? What it ultimately gives you is the traditional reporting. You need to need that. You need your ISO 4406. You're going to get the ability to report all this information as you normally would, and everything is saved as well. And you get the ability of looking at thumbnails. So for every classification, you'd be able to see every single thumbnail that you analyze. So that's what it's going to give you. Now, what else does it give you besides that? In addition to looking at the classification codes, you actually have the ability of doing an analysis and doing classification by type of wear. So this wear classification is mentioned in the ASTM D7596, but it's actually mentioned in great detail in the NORIA Wear Atlas. The NORIA Wear Atlas, what I really like about it is that it gives you a lot of images. And in the case here, we actually train the software to go through the NORIA Wear Atlas and train itself to actually make these classifications capable. So at the end of a run, you can actually have the classification to see how many of different classes of particles, what's the percent of total, the size, of the particles, all the statistics. But in addition to that, if you press the thumbnail button, you'll be able to see the thumbnail images and prove it to yourself that they are there. So in some cases, you do want to see how many water droplets there are in your oil. That could be a bad thing. You may want to see how many air bubbles there are in your oil. That could be a bad thing. You can delete them if you want, but sometimes it's important to see that. So you do get all this information where you can see the thumbnail images. And of course, you can do printed reports as well. The printed reports are where you normally would get from any type of automated particle counter with respect to the ISO codes, but you also get the classification. You get some system data, but of course you get all the thumbnails as well. So all that's available from dynamic imaging. What does all this give you? So at the end of the day, it does give you a way of being able to identify problems right at the field. In addition to that, there is no expert required. You can set it up to give you pass fail. So one of the things that the ISO 21018 mentions is the ability of some of these new techniques to be able to give go, no go type of criteria for users. And here you go. So because there is an ability for dynamic imaging to differentiate particles by shape, not just size, you are able to identify how many water droplets there are, or concentration by concentration, how many air droplets, how much debris there is. So a user or a manager could set up a pass-fail criteria. So when these systems are taken out into the field and tested right at the point of test of the equipment, you can get a pass-fail criteria, and you can actually see if it passes or not. So what are some typical results? I thought I'd go through a couple of those. These are some realistic results. So anything you see, these big white lights, these balls with big white spots in the middle, those are water droplets, and these darker balls with white little pinhole in there, those are air. So you can actually get your classification codes. You can see all the water droplets, all the air droplets. You can delete them or eliminate them if you want. But keep in mind, water droplets are all different size. Here's some 60 micron water droplets, and here's a 19, or here's a 9 micron water droplet. But so it's always important to make sure that you analyze all your sample and see what you got before you delete anything. But you can delete air bubbles and water droplets if you'd like. Here's another example of some piston engine aircraft oil. Again, you see some water droplets here, and you see some particles stuck to them, but you see there's definitely a good number of real particles in there. Again, we don't know what they are, and if you do need to know what they are, you could save your sample and send them to the lab. The goal here is you can get this result right there at the point of test. So right there what the machine is, you draw your sample, you do your analysis, and you make the determination right there if you have a problem or not. If you ultimately want to send this into the lab to see if any of these, what kind of metal they are they copper, or are they iron, you can do that. You can send that in, but this is meant to be a quick, right there, give you an idea of everything that's in your oil, so you could take some corrective action immediately. And again, some other examples of some particles. More particles here. You get some soot particles. You can still see through them pretty well because of the fluidics design of a lot of dynamic imaging instruments. So ultimately, what this is going to mean for you is you are going to be able to get the traditional reporting that you would normally get for a light blockage system or an APC. You do get the ability of having a system that is portable and can be used in the lab as well. And you get the objective evidence, right? So the fact that you get the ability to take this out in the field, or you can use it in the lab, do an analysis, and really quickly see what's in there, it ultimately means that you don't need an expert, right? Seeing is believing, no waiting for lab results, and you do get comparative results with an automated particle counter as you do with a particle contamination monitor when it comes to dynamic imaging. And we do have results that show how a APC or automated particle counter does match our dynamic image analysis instrument. And ultimately what this means that there's no time wasted. You can make a decision right there whether you have a problem or not. Ultimately, should you consider dynamic imaging as a particle contamination monitoring? It depends. If again, it'll give you the ISO codes and classification of where particles for particles all the way down to a micron, sometimes a little bit lower than that. It does give you the ability of being portable without the loss of resolution. This is the technique that lends itself for that it can be portable, and you can do this test at the point of where the machinery is. Having the thumbnail images does offer immediate proof as to what's in your particle, what's in your oil. Is it something you should worry about, not worry about? And you don't have to be an expert. A picture says it right there. Right. And it can differentiate between bubbles and water droplets and real particles. So, and again, very flexible fluidic design. So dynamic imaging, it doesn't care how it gets the particles in front of it. It could be connected online to a 55-gallon drum. It could be connected to an external vessel. It can be connected directly to a sampling syringe. So anyway, you want to be able to suspend the particles in front of the instrument. Usually dynamic imaging has no problem with that. And that's it. So I appreciate your time. Thanks for watching this presentation. And if there's any questions, here's my email. Please contact us. Thank you.